We found a caterpillar.
The defensive mechanisms of Lepidoptera come in various shapes and sizes. The most common behaviors start at the larval stage and continue throughout adulthood. These behaviors include crypsis, physical attributes, and chemical behaviors. Crypsis involves the ability of the caterpillar or moth to avoid detection by predators, which usually involves some sort of camouflage or even mimicry. Physical attributes developed by the Lepidopteran to avoid predators includes vibrant body color or sharp spines and hairs. Another mechanism to deter predators is the secretion of chemicals through glands.
They're soft-bodied organisms. They don't have a chance. They don't have much ability to fight back or anything, but they do have all those, the urticarial hairs, the secretions, the ingested materials that they retain in their own bodies. The number one predators, the top predators we all have are other insects, okay? So for every insect that's eaten by a bird, there are probably 10,000 that are killed by other insects, either insects that pounce on them and eat them right there, or more importantly, that are parasitoid. And some of those chemical defenses are outright toxic to something that might eat them. Some of them are just deterrents. You just would not want to eat them.
The eastern black swallowtail caterpillars have horn-like organs extruding from their head called osmeteria. When they're being threatened by a predator, they rear up and attempt to cover their predator with a chemical repellent excreted from the osmeteria. This chemical mixture is made of volatile organic acids, which repel and even sometimes kill predators. This tactic of defense is particularly effective against the attack of ants, which is a common problem for the black swallowtail. They've evolved this method of chemical defense to increase their survival value.
Those tend to only be turned out inside out when there's some sort of an irritation, some sort of a stimulant. When the caterpillar detects that something is there that might pose a threat, it will put those out and begin to produce the chemicals. What we call warning coloration in insects, there's got to be something behind it. The coloration is the bark. Okay, that's the warning. A dog growls at you, barks at you, you're less likely to want to pet it, much less grab it and eat it. Okay, but there's got to be a bite behind it.
Aposematic coloration, or warning coloration, is used by chemically defended prey to advertise their toxicity to potential predators.
Oh, sorry.
Fuck him again.
The survival value of aposematism is likely derived from predator avoidance learning, where predators become educated on the unpalatableness of prey after consuming the prey and experiencing noxious side effects. The educated predator will therefore reduce attacks of subsequent aposematic prey over repeated encounters, as it begins to associate the toxin with the visual warning signal displayed by the prey.
They rear up. As a posture, it becomes another visual signal, not a color signal, but a visual signal that they're aware of your presence and they've got something to come at you with. So you need to be careful. The other thing is just to make that more available. So like the osmeterium, I mean, it's by rearing up and spreading those things out and everting them, it's just making it more available so that it can do its job. And then many of of course, the papilionids, both as larvae and as adults, tend to be very brightly colored. And so that's an example where the warning coloration and the chemical deterrents sort of work hand in hand.
The Gulf fritillary adult butterflies have glands on their abdomens that secrete chemical defenses that are particularly effective against birds. They, however, lack this type of defense in their larval caterpillar stages.
Most of their defensive structures are dorsal and lateral, and so ventrally they're going to be against the substrate. They've got to be open down there somewhat because they've got to move around, and they've got to have their mouth parts available to eat. So most of the defensive structures and defensive glands are going to be dorsal and lateral.
Giant leopard moths, in their larval stages, are known as giant woolly bears. They are called this because their body is covered with bristles called setae. These bristles cause physical discomfort to predators, but they don't sting or contain any sort of chemical defense. Therefore, Their main defense mechanism is not chemical, but it's nonetheless very effective.
They said I couldn't wear hiking clothes to work, but they didn't say anything about worm jewelry.
Okay. Well, many insects are, their cryptic coloration is mostly a matter of hiding themselves because they're ambush predators, and they're blending in with the background so that their prey won't see them. But the Lepidoptera, if you're looking at Crypsis in general, which would include not only cryptic coloration, but simply hiding underground, hiding in leaf litter, other types of avoidance behavior. Most lepidopterans are things that you don't notice because they're so cryptically colored. They're small, and by the way, size is an important part of Crypsis. Small size is often selected for because it makes it easier to hide and be less conspicuous. The basic idea, going back to just simple Darwinian principles, is that those organisms that avoided being preyed upon or were able to be better predators because of their cryptic coloration or other types of crypsis besides coloration, they were able to survive, be well nourished, and then pass their genes along to their offspring. So it's as simple as that. Survival of the fittest. I think the way I would understand the development of Crypsis evolutionarily is that it often develops more as what we would call a pre-adaptation. In other words, it develops in the animal prior to its use in the way that we see it. So we look at it and we think that the organism has developed this drab, grayish blend into the background coloration as a way of hiding. Well, maybe it didn't. Maybe it's just that that's where it lives. It's surrounded by the same materials. Obviously it's eating the material that it lives in, and it may absorb the chemicals from the plants it eats. This happens a lot with some of the caterpillars, and many of the lepidopterans are what are called urticarial hairs. Urticarial hairs are hairs that sometimes come off, sometimes do not come off, but they are very irritating, just like getting fiberglass or something on you that makes your skin itch, and it works its way down into your skin, or tiny little glass crystals. These urticarial hairs will break off. Some of these little hairy, fuzzy caterpillars, they'll break off and cause a lot of irritation.
Caterpillars, despite their soft bodies, have evolved many strategies of defense. These strategies are their physical appearance, various types of chemical defense, and the many behaviors that defend them from predators. These defensive mechanisms of the lepidopterans were most notably seen in the chemical defense, warning coloration, and posture of the eastern black swallowtail. In addition, physical protection was exemplified in the Gulf fritillary caterpillar and giant leopard moth caterpillar. Cryptic coloration was also observed in the imported cabbage worm. The defensive strategies seen in the larval stages of these insects decreased predation, thereby improving their chances of entering the pupa life stage and reaching sexual maturity after metamorphosis.